Water flows out of a faucet with a velocity of 0.75 meters per second. The faucet has a width of 1.5 centimeters. Assuming the area the water flows out of is a perfect circle, at what vertical distance below the faucet is the width of the water equal to 0.75 centimeters? So let's see, we've been doing fluid flow. We're talking about water here, so that's an incompressible fluid, which means the continuity equation, the only equation we've listed for this section, for this case, would simplify to A1 V1 is equal to A2 V2. So hopefully I can just take these quantities and figure out what to plug in. And maybe, let's see, like the faucet has a width of 1.5 centimeters, so maybe I could say like an A1 would be equal to whatever area that corresponds to. Width, that's like diameter probably, since it says it's a perfect circle there. And area would be pi r squared, right? So in this case, that would be like pi, I think I'll just write 1.5 centimeter over 2 squared, and we can figure out later what that is. And we've got a V1 is equal to 7, let me try to make that 7 better, 75 meters per second. And let me see, I think we got an A2 there in that 0.75. A2 is equal to pi, since that's a width of 0.75. I think we could kind of do the same thing as we did with A1 and say 0.75 centimeters. Maybe we can convert later to meters if we like. But divided by 2 would give me the radius, and then squared, and that's something else that I could compute. And then I could use the continuity equation to calculate V2, right? Is that going to answer this question? Well, it says at what vertical distance below the... Oh, boy. Okay, hang on a second. Hang on. I think I got to go back to the drawing board on this one. So what do you do when that happens? I think I might have missed one little line there when I did that. Okay, what do you do when that happens? So we thought we were just going to be able to use that equation and things would be easy, right? So what do you do when things are not easy? My answer is you draw a picture. So instead of starting with the formula and all those quantities and stuff, I've erased them all. Maybe some of that would be useful, but I'd like to draw a picture and maybe see what that tells me. So I'm imagining that this is maybe the faucet here. I don't know. Let's maybe put a little bit top to it here. And then we're thinking about water coming out of this circular region. And you know how water can sometimes, especially if it's not coming out very fast, it'll like kind of do like this, right? Narrow as it goes down. And eventually far enough down, it might separate into droplets. But I think we're assuming that that's not going to happen here. And in that sense, the velocity that we called V1 would correspond to what it's moving at downward right when it leaves the faucet. So V1 is equal to 0.75 meters per second seems appropriate there. Now, I think we were correct what we wrote earlier about A1 and A2, but I don't know if we need to calculate them, because the thing to recognize is that we're talking about this to some region that is somewhere below where the width is half of what it was, which, I mean, I don't know if I've drawn this to scale, but let's maybe assume that that's like down here, right? And I'm going to say that if the width is half of what it was, that really corresponds to like the area being a quarter of what it was. So maybe one way I could write that is if I say this corresponds to A2 is equal to 1/4 A1. But that's the point where maybe I could use the continuity equation in my reasoning and maybe not use it the way that I expected to. Because really, if A2 is a quarter of what the area was at the top, I didn't label it yet, but maybe I can just put an A1 up here, right, for reference. That would imply that V2 should be 4 times as fast as V1. In other words, that's what we're looking for. V2 is equal to 4 V1. And what is what is 4 times 0.75 is 3/4, so 4 times that would be 3, right? I think the first time I did this, I had to use a calculator for that, which is okay. Okay, but that gives us 3 meters per second. So that's great. And we saw earlier that we could do that, but I think I was just thinking about stuff wrong. And now, since the actual question is what vertical distance, so in other words, if we're talking about like how far down, that distance d, that's really the thing. I don't know if I left enough space there for a question mark. But how could we do that? Well, we do know what the acceleration is here, right? This is just free fall. So we can say acceleration is equal to g. So I've got two speeds. I've got an acceleration, and I'm looking for a distance. I think we have a formula for that in kinematics, right? v2 squared is equal to v1 squared. Or wait, was that the version we used? Let me change it. We'll make it v2 squared minus v1 squared. I think this was the version we actually had. Maybe I'm wrong. I don't know which side of the equal sign we want to put stuff on is what I'm worrying about. But it was equal to 2a times d, which in this case we can just say 2 times g times d. And again, we're trying to solve for d, so that would suggest that d is going to be equal to v2 squared minus v1 squared over 2g. So then I could say, okay, 3 meters per second squared minus 0.75 meters per second, whole thing there squared. Actually, maybe I shouldn't say whole thing, just all with the units, right? Divided by 2 times 9.81 meters per second squared. And that I can enter in my calculator. And my calculator says 0.4300458716. Looks like 2 sig figs is good enough, so that should be 0.43 meters. Looks like the unit would be, which maybe I could rewrite that if I like as 43 centimeters for the final answer. Let's go ahead and check that with the slide. All right, that worked.